Hi, welcome back to the series of functional safety sessions. I am Tota Krishna Hema, your functional safety expert. So in this video, we are going to discuss about IEC 61508 functional safety standard overview. So IEC 61508, what IEC stands for is International Electrotechnical Commission. So here you got to know that it is an international standard, right? So this is nothing but an international standard which is defined for functional safety of electrical or electronic or programmable electronic safety related systems. So from now on we are going to abbreviate, or while talking also we say it as EEPE systems. So it is about on how to analyze, that is how to bring in the requirements and allocate the requirements and realize, that is implement and start the operation and safety validation, and about operation, that is how it is performing during in the target environment or in the field till the decommissioning. So all these phases from design to decommissioning including deployment will be covered as part of 61508. So from concept phase to decommissioning, it will be there in this standard. So IEC 61508 is applicable for all industries and it is a basic functional safety standard. So from this, if you say like our ISO 26262, that is functional safety for automotive, is derived. Similarly, we have functional safety derived for locomotives, functional safety derived for aeronautics. All these standards are derived from 61508 only. So this standard explains functional safety as this. The definition of functional safety as per 61508 is part of the overall safety relating to the EUC, that is equipment under control. So in terms of car we will have ECUs, no? So the same way, like it is, since it is a common standard, so it is mentioned as EUC, equipment under control, and EUC control systems which depends on the correct functioning of the EEPE safety related systems, other technology safety related systems, and external risk reduction facilities. So this is the standard definition of the functional safety as per IEC 61508. So the main goal of functional safety as per IEC 61508 is to avoid failure. In case if we are not able to avoid the failure, then the failure should be within the known or safe mode, that is reduction of risk to tolerable level by applying safety functions. So these things, like whatever we have discussed, the goal of the functional safety will be discussed will be furthermore elaborated in the upcoming slides. So IEC 61508 has 7 parts. So 7 parts are further divided into 3 groups. So part 1 to 3 is about requirements, normative requirements of the standard. So everything from 1 to 3 is talking about the requirements. So if you are implementing 61508, so what we are going to implement is 1 to 3 parts we are going to implement. So one is about general requirements, so general requirements of the standard, and 2 is about EEPE safety related system requirements. 3 is about software requirements. Okay, and part 4 is talking about definitions and abbreviations. Part 5 to 7, it is about guidelines and examples for the development which is defined in part 1 to 3. So it gives the guidelines on application of IEC 61508, and it gives the examples, it gives the methods and the techniques which are used to calculate the calculations inside in 2 and 3. Part 2 and Part 3. So Part 5 is about examples of methods for the calculation or of SIL levels, that is safety integrity level. 6 is about guidelines on the application of IEC 61508 Part 2 and Part 3. 7 is about overview of techniques and measures. So it is giving more information about how to implement Part 2 and Part 3 with examples, with methods, with techniques. Okay, and we have two core concepts, or these are the basic pillars of 61508. One is safety life cycle. The other thing is probabilistic failure approach. So these two are the core concepts, so which we are going to discuss in the next slides. Here is a safety life cycle as per IEC 61508. So it has 16 phases, and 16 phases are further divided into 3 groups. So phase 1 to 5 is talking about analysis of a product, EE, product. Okay, and phases 6 to 13 is about realization of product. So here you are going to implement the product, and you are going to install it and start it. And 14 to 16 is about operation, maintenance, and also how to decommissioning it, how to dispose it after the life cycle. So if you see 1 to 5 is about analysis. So it includes the collection of requirements. It includes analysis of requirements. So how it is initiating is about concept phase 1, that is phase 1 is concept, phase 2 is about scope definition, phase 3 about HARA, that is hazard and risk analysis. In ISO 26262 we have hazard analysis and risk assessment, but wherein 61508 it is talking about hazard and risk analysis. And phase 4 is about overall safety requirements. 5 is about safety requirement allocation. Okay, 1 to 5 is about analysis. So 6 to 13 is about realization. Realization is nothing but how to implement it and how to make it function, means like how to make it validate in a target environment, how to initiate it. All these things will be part of this realization. So 6 to 13. 6, 7, 8 is about planning. 6 is about planning of operation and maintenance, and 7 is about overall safety validation planning. 8 is about overall installation and commissioning planning, how to initiate it. So this is about planning. Okay, and 9 is about safety related system realization. Realization is nothing but how to implement it. Okay, 10 and 11 are about the safety related systems, other technologies, and say external safe risk reduction facilities in for 11. So 10 and 11 are out of scope in this standard. And from 8 we have overall main installation and commissioning. From 8 to 8 we have 12 phase. So here we have 8 we have planning activity, and at 12 we are going to implement it. Overall installation and commissioning planning will become overall installation and commissioning implementation or realization. Okay, so 7 is about overall safety validation planning. So in realization, how do you do it? Is overall safety validation you perform. Okay, and so we are done with 6 to 13 realization phases. So how about operation? So once after initializing and once after validating the product in a target environment, then we are going to start the operation. So based on phase 6, that is overall operation and maintenance planning, we are going to perform overall operation, maintenance and repair. So in that, if there is any changes required or any modification required and retrofit the equipment as per the safety life cycle, then we are going to do it as a part of phase 15. And in phase 16 we have commissioning or disposal, how to throw it away in case like after the life cycle time. So we are going to dispose it very safely to the environment. It should not cause any harm to the environment. So we need to consider all those things in a safety life cycle. So I hope you remember 1 to 5 is about analysis. It talks about concept to requirement allocation. So 6 to 13 is about realization. It is talking about planning to safety validation. So 14 to 16 is about operations, maintenance and repair to decommissioning. So the next thing is we spoke about the life cycle till now. So the main goal of functional safety as per IEC 61508 is to avoid failure, or if failure is essential, then to get the unavoidable failure into safe mode. Even if the failure occurs, it should be within the known safe limits. That is reduction of risk to tolerable levels by applying safety functions. So this we spoke in the previous slides. We are going to explain it here furthermore. IEC 61508 has following views on risk. So how to deal, or how the risk could be, something like that. So zero risk can never be reached. Only probabilities can be reduced. So in any product, if you see any EEPE systems, so you cannot have zero risk. So risk will be there, but you have to estimate the probabilities and you have to try to reduce the probability of risk. Okay, and the second thing is non-tolerable risks must be reduced. The next thing is optimal, that is cost-effective safety is achieved when addressed in the entire safety life cycle. Three things: zero risk. Without risk, any product is impossible, but we have to target on the reduction of probability of risk. Second thing is non-tolerable risk must be reduced. Third thing is about cost-effective safety. Okay, the error occurred in prior phases should not be repeated in next phases. Like the error occurred in concept phase should not reappear in risk analysis phase or HARA phase. So it should not reoccur in specification phase, or it should not reoccur in design phase, or it should not reoccur in installation phase or maintenance phase. So this kind of thing, like we have to take care that an error occurred in prior phases should not be repeated in the next phases. And till decommissioning. So till decommissioning we have to ensure how to avoid this not to repeat again is like we have by the verification activities, by strengthening the verification activities, also by finding out the root cause and avoiding the root cause which causes the same kind of failure again and again. So of the EPE need reliable production. So let us talk about HARA. So HARA is hazard and risk analysis. So here in IEC 61508 it is called as hazard and risk analysis. The EUC, that is equipment under control, risk shall be evaluated or estimated for each determined hazardous event. So either quantitative or qualitative hazard and risk analysis techniques may be used to arrive at the SIL, and the quantitative analysis of hazards is a framework based on 6 categories of likelihood of occurrence and 4 categories of consequences. So you can see the tables in the next slides. So these are the categories of likelihood of occurrence. So category, definition, range. So range is failures per year. Failures per year. So category is frequent, is many times in a year, that is greater than 10 power minus 3, that is 1 out of 1000. Okay, probable is several times, many times is frequent. Next is several times in a year, several times in lifetime, that is 1 out of 1000 to 1 out of 10,000. So occasional is once in lifetime, that is 10 power minus 4 to 10 power minus 5. Remote is unlikely in lifetime, that is 10 power minus 5 to 10 power minus 6. Improbable is very unlikely to occur, that is 10 power minus 6 to 10 power minus 7. Incredible is cannot believe that it could occur, that is lesser than 10 power minus 7, that is 1 by 1 after 7 zeros. So we have discussed about likelihood of occurrence. Now we have to discuss about the consequences. So consequences is catastrophic, that is multiple loss of life. There are so many people died at the event, at hazardous event. So next is critical, loss of single life, one person died, something like that. Marginal is major injuries to one or more persons. Negligible is minor injuries at worst. So here is the graph, here is the matrix which is in between likelihood of occurrence and the consequence. So you can say, like, frequent and catastrophic is 1, probable and critical is 1, occasional and marginal is 3, remote and negligible is 4, and you have 1 to 4 classes. So here 1 to 4 classes are explained, that is class 1 is unacceptable in any circumstance, class 2 is about undesirable, that is tolerable only if risk reduction is impracticable or if costs are grossly disproportionate to the improvement gained. Class 3 about tolerable if the cost of risk reduction would exceed the improvement, and class 4 is about acceptable as it stands though it may need to be monitored. So class 1 is high and class 4 is low. So SIL is safety integrity levels, so provides target to attain for each safety function. SIL has 3 measures, that is systematic capability SC, architecture constraints, and probability of dangerous failure analysis. So in the beginning, like we spoke about 2 different things. The core concepts of IEC 61508 is safety life cycle. Safety life cycle has 16 phases, 3 groups, and the next thing is about probability of dangerous failure analysis. So when we are talking about SIL, safety integrity level, this came as a third part. So how to do it, we can further discuss in the next slides, but let us discuss about systematic capability. Systematic capability is a design of what is a measure of design quality. So how the systematic approach to calculate the capacity of the design, something like this, and each device in the design has a SC rating, systematic capability rating. So the SIL of the safety function is limited to smallest SC rating of the devices used. So requirements for SC are presented in a series of tables in part 2 and part 3. The requirements includes appropriate quality control, management processes, validation and verification techniques, failure analysis, etc. so that one can reasonably justify that the final system attains the required SIL level. Probabilistic failure approach. The probability metric depends on whether the functional component will be exposed to high demand or low demand. So there will be a table with low demand and high demand ratings, and high demand is defined as more than once per year, and low demand is defined as less than or equal to once per year, which is defined as a part of IE 61508 part 4 for functions that operate continuously, that is continuous mode, or functions that operate frequently, that is high demand mode. SIL specifies an allowable frequency of dangerous failure. For functions that operate intermittently, that is low demand mode, SIL specifies an allowable probability that function will fail to respond on demand. So the difference between the function and system we have to see here. The system which is implementing the function might be an operation frequency like an ECU for deploying an airbag, or a function like airbag deployment might be in demand intermittently. So here is the probabilistic failure approach. So low demand mode and high demand or continuous mode are discussed. So for SIL 1, it is average probability of failure on demand is 10 power minus 2, greater than or equal to 10 power minus 2 to lesser than 10 power minus 1. So in case of high demand, it is greater than or equal to 10 power minus 6 to lesser than 10 power minus 5. For SIL 2, it is greater than or equal to 10 power minus 3. And if you see here, like for SIL 3, one dangerous failure in 1140 years. So something like this it is. You can read here from the table. So verification as per 61508, all the testing activities in 61508 should be aligned with the requirements of SIL level derived and to achieve the SIL level. In software implementation, all modules should be unit tested with ensured statement coverage, branch coverage, function coverage, MCDC coverage. So the difference between ISC 61508 and versus ISO 26262 is ISO 26262 is specifically derived for automotive industry. ISO 26262 is very specific hazard analysis and risk assessment is available and standard, wherein 61508 has more flexibility and has multiple methods to do hazard and risk analysis to evaluate hazards. So ISO 26262 is about embedded software and which should be followed, which MISRA guidelines need to be followed. MISRA abbreviation is Modern Industry Software Reliability Association, so defined for C and C++ languages. With this I came to the end of the topic. Thank you so much.